Thanks all for joining today. Please use the Q&A option to submit questions, and Hima and I will be having this discussion, and we'll take up questions from the audience in the course of this webinar. So by way of introduction, so my name is Krishnaram Kentapadi. I'm the chief scientist at Fiddler AI. We are an enterprise startup building model performance management related tools. This includes model monitoring, explainability, bias, fairness, and so forth. With me today is Professor Hima Lakaraju. Hima, would you like to go ahead and introduce yourself?
Yeah, thanks so much, Krishnaram. Hi, everyone. My name is Hima Lakaraju. I'm an assistant professor at Harvard University. And I work on the topics that Krishnaram just mentioned, which is things like explainability, fairness, and data set shifts, model monitoring, and so on. Excited to be here today with all of you. Thanks.
Thanks, Hima, for joining us today. So let me start with just a broad question about what inspired you to work on responsible AI related topics like fairness, explainability, model monitoring, privacy, and so on.
Yeah, so I think for me, I think came close to working in this field like quite early, when probably these terms were not so popular. So when I was a young PhD student at Stanford in 2012, 2013, by then I already had a couple of years of working at IBM Research, where I was mainly working on things like social network analysis and topic models and Bayesian frameworks and so on. But a lot of the applications that I was focusing on prior to my PhD were all about recommender systems and ads and friend recommendations on social networking sites and so on. So when I moved to some NLP as well, so when I moved for my PhD to Stanford, that's when I felt like I wanted to do some kind of different kinds of applications, potentially those with larger impact on people or on society and so on. So I started thinking a lot more about healthcare and law and policy, and once I started thinking about these kinds of applications and how machine learning could potentially fit in or help those kinds of applications, then naturally some of the things that sort of started springing about were things like, can decision makers understand these models? We need to make sure that these models are fair and they're not sort of discriminating against any sort of set of subgroups in the data. So I think these topics organically came into the fore in my research as a result of sort of choosing to focus on different kinds of applications during the start of my PhD. So yeah, that's where I would say it all started. So let me actually turn that around maybe and ask that same question to you. So Krishnaram, how did you get excited about these fields of responsible AI? When did you start working on them? How did you gradually move into these fields?
Even for me, I had a similar journey. During several years back, during my PhD, I had the opportunity to work on privacy preserving data mining. So these are the days when even AI or the connotation of AI was very different. I remember instructing a course on artificial intelligence, and it did not even discuss machine learning. It was more about path planning and A-star algorithms and so forth. During my PhD, I had the opportunity to work on a few different definitions and models of data privacy. This included writing one of the initial early papers on differential privacy before even the term differential privacy came into effect. But afterwards, after my PhD, when I joined industry, I noticed a little bit of disconnect. There was a lot of interest on privacy related topics in academia, but in industry, I did not see as much interest. I kind of call that almost like a privacy winter for a few years. So I started working on other kind of topics like web search, recommender systems, even computational education, and so forth. But later I saw that there was a kind of resurgence in interest in privacy, partly because of regulations. In particular, I was at the LinkedIn AI team back in 2017 timeframe, and this was when European Union's General Data Protection Regulation, or GDPR, was going to take effect in a few months. There was a scrambling at LinkedIn as well as several other tech companies to figure out how to comply to these regulations. And even more broadly, even apart from regulations, there was always a desire to make sure that when, say, LinkedIn provides different types of analytics to advertisers or other enterprise customers, we do not accidentally breach user privacy. We do not accidentally let a malicious advertiser figure out which user clicked on an ad or viewed an ad. So there was an interest from that angle as well. So I again started working on privacy with a more practical focus, industry focus. Then the other thread I noticed at LinkedIn was that LinkedIn operates in the hiring domain, professional networking and hiring domain. And if you think of domains, say once we go beyond domains like criminal justice or lending, hiring is a domain where any bias can have a potentially lifelong impact to the affected users. So naturally, like at LinkedIn, we were very keen to understand whether the machine learning models and systems performed well for different subgroups. So there was an interest from people like me as technologists and machine learning researchers and engineers. There is also an interest I saw from the enterprise customers of LinkedIn. They were asking LinkedIn how LinkedIn can help improve, let's say, the diversity of their workforce. What can LinkedIn do to help address some of the requirements or needs of these customers? So there was a kind of nice interest both from the business or the product side and also from a machine learning side. So that's how I again started getting back into topics like privacy and fairness. And then after LinkedIn, and after specifically working on one of the applications at LinkedIn, the next thought was, how do we now scale this to all applications at LinkedIn? We then built a toolkit called LinkedIn Fairness Toolkit, and subsequently open sourced it as well. And then my thought was, now can we go beyond just LinkedIn applications? And that brought me to Amazon Web Services, where I had the opportunity to work on some of the fairness and explainability toolkits. And at Fiddler now, we are now again like offering such tools, not just for one cloud provider or on-prem, but across cloud providers and across both on-prem and cloud-based customers. So that's my perhaps a long journey to working on topics like fairness and privacy. So can I ask you a related question, Hima?
Yep.
So I can see, let's say, from an academic viewpoint, right, there's a lot of interest in these topics. So often I see researchers who are interested in topics like privacy, or there's a substantial overlap with the researchers who are also working on fairness and related topics. Why should, say, companies or enterprises care about such practices? So why should they care about maybe fairness or privacy or model monitoring?
So I think, I mean, so yeah, it's totally true that I think there is a lot of emphasis these days in academic research on these kinds of topics. Now, coming to the question of like, should industries, and again going all the way from like large to small scale industries, should they care about model monitoring? or like, I think we're using the term rather broadly to refer to a bunch of things, but like, should they care about explainability or fairness, or like, thinking about data distribution shifts and so on, and why should they do so, I think is an important question, especially in today's day and age. So with, I think, like, let's say a decade back or so, maybe the sort of applications of machine learning models were limited to certain areas, like maybe, they were sort of like looking at very specific applications and so on. Now I think machine learning models are being like used ubiquitously, right? So, people are developing a model for a specific purpose, and that's being employed for like a totally different purpose, whether it's in practice or whether it is like in research context. So given that these models are affecting lot of critical important decisions, ranging all the way from like recommending your favorite movies to like ranging all the way, to like, as you said, like hiring and healthcare and so on. So given that, I think these topics have come more into the fore, because, for example, if a model that is being used to, let's say, make insurance decisions, right? If that is discriminating against a particular subgroup in the population, that's a problem, right? So we are now affecting the lives of people. We are now affecting the actual outcomes in the real world of people. And now machine learning is not just restricted to like, let's say, recommending your favorite movies, right? So as these models are being used to make more and more critical decisions, the emphasis or the importance of these kinds of topics is, becomes, I think, almost like evident, right? So similarly, when a model is making again a critical decision about like diagnosis in a hospital and so on, it's important for a doctor to like really understand why the model is saying what it is saying, so that they can, sort of look at that recommendation or prediction from the model in an objective way and look at it, think about it as, do I want to trust this or not? Do I want to use this in my own final decisions or not? And so on. So for that purpose, explainability can be very important. And lastly, coming to some of this other space, or the term that we are using loosely, which is model monitoring. In that case, I think essentially, if we were to sort of, if we care, if any company cares about, let's say, accuracy of the model over time, because data often keeps changing. For example, COVID was a very recent, and I think an experience that all of us can relate to. All the models that were sort of functioning well pre-COVID in terms of, let's say, accuracy or other metrics, took a hit once COVID struck, because, the customer buying patterns and a lot of things changed during that time. So a lot of these models had to be recalibrated, right? So in order to make sure that your models are still effectively working, as the data shifts or changes, you need model monitoring, irrespective of what your application is. Otherwise, without even realizing things, you might lose, a lot of revenue or have a lot of customer attrition if you don't continuously monitor what your models are doing. So that's how I would think about the practical relevance of a lot of these aspects.
Thanks, Hima. Let me just remind the attendees, please feel free to submit your questions through the Q&A feature at the bottom of the webinar panel. Yeah, and please feel free to like maybe vote on the different questions as well. In the course of this webinar, will take up questions from the audience. So to going back to Hima's comment, to me it seems like responsible AI or model monitoring is not only the socially responsible thing to do, but it's also pragmatic from a business angle. So if it takes the dimensions like privacy, fairness, explainability, or monitoring of the performance or accuracy or data drift of the models, often the initial few like privacy, fairness might be driven by either regulatory reasons or from a reputational reasons. If so sometimes, like when I talk to customers, I emphasize that it's often in the best interest of an organization to proactively stress test their machine learning systems for bias or for even privacy leakage and so forth, rather than be reactive. It has become relatively easy to vet such models even from outside the organization. We have seen this a lot in web services, this facial analysis, facial recognition related softwares, or web search, photo tagging, and so forth. But turns out that it's not even limited to just the online services. Even we have seen instances where, say, when it comes to credit card approval or credit card, the amount that gets approved on credit card, if somebody is really determined, they can test even such systems and discover any biases or unusual behavior of the systems. So it's in the best interest of an organization, even in domains which may not be regulated, to stress test the models, just like we do pen testing for security. I think that it's great to do the similar pen testing or stress testing for bias and fairness and for any privacy breaches. When it comes to, say, explainability, there is often an interest even without regulatory or reputational factors. Say when there is a complaint, or when there is some reason to diagnose what's going wrong, the customer support representatives or the data scientists want to understand how these models are behaving. So one of the unique aspects of machine learning systems is that even the data scientists themselves, who might have trained the models, may not be in a position to understand how the models are behaving. Uh, so we all, as say, machine learning researchers and practitioners, have a good understanding of the methods used to train the models. The methods like stochastic gradient descent are fairly simple to state and to understand. But when these methods are applied on large amounts of data, the resulting output is the machine learning model with several millions of parameters or several layers of a deep neural network, which is hard even for the model developer themselves to understand. That's one domain where having tools for explaining the models goes a long way to debug the performance, or even to figure out which features are most important for the model. If I have to go and collect more features or design new features, how should I where should I invest my time and effort? Or when it comes to data, which parts of the data are most relevant for the performance of the model? Are there parts of the data which may be mislabeled or corrupted, and as a result is hurting the performance of the model? These are kind of places where having explainability related tools definitely help. And finally, there is often this thought that we have done a lot of testing and validation for the model, and then let's deploy the model, but not enough emphasis on monitoring the model once it's deployed. Yeah, as Hima mentioned, whenever the real world conditions change, this becomes a big concern. To complicate things, machine learning models are often very forgiving. Let's say that in a real world system, there is a workflow of data and models, and somewhere upstream, maybe the data format got changed. Instead of the data being in inches, now somebody has changed that data to be in centimeters. Uh, Still, we are going to get a numeric value, and the machine learning models may just consume that value without realizing that the semantics of that value has now changed. Unlike, say, traditional applications which might crash if something is gone wrong, with machine learning systems, they're often forgiving, and that's another reason to monitor for data integrity or data corruption or data drift issues. And of all these dimensions, I would say that monitoring is often directly tied to the business impact, the business revenue or profit. And so there's a strong incentive for organizations to monitor the models, even in domains which do not have regulatory or reputational harm or other concerns.
Right. So I think we have some questions on the Q&A. Maybe we can go over them in order. So what would an ideal ML monitoring framework look like? I can start a little and then I'll hand it off to Krishnaram to discuss more. So I think maybe it just would help to actually define this, phrase that we are using, model monitoring itself first. So oftentimes, I think when we think of model monitoring, right? So at a high level, in a sort of like a colloquial language, we can think of this as keep regularly making checks on your model so that that it is behaving in the way it is expected to behave, right? So that roughly in a sort of colloquial sense is what we are referring to as model monitoring. And this can sort of involve a variety of things. For example, one could be keep monitoring the accuracy of your model, right? So that, I'm sure is pretty valuable for like every application, every enterprise and company, because you don't want your accuracy numbers to dip, as even a small percentage change in accuracy could mean a lot of lost revenue in dollars, right? So I think monitoring the accuracy of your models, sort of consistently on the data that you're getting, I think that is one of the key aspects when you think about model monitoring. So one is accuracy monitoring, and the other thing is to ensure that your model is again not discriminating on a consistent basis against certain protected subgroups, right? So whether it is a certain racial subgroups or whether it is certain gender subgroups, maybe when you deployed your model it was functioning fine, but as your sort of data shifted or changed or took a drastic turn due to some external events, we still need to make sure that the models that we have are not discriminating against subgroups. So performing these fairness checks consistently to ensure that there is no undue discrimination is another aspect of monitoring, right? So accuracy monitoring, fairness monitoring. And then the third one could be that your model is using relevant and not spurious features as it is making its predictions over time, right? So maybe initially your model was doing the right thing, it was using the relevant features when making predictions, but again, due to certain changes in the data, your model may now be using some spurious features for making predictions. So it's important to monitor those, the rationale behind your model predictions consistently, and that's where explainability can come into picture, where you're also sort of peeking into the model and monitoring it to make sure that it is using the right kinds of features over time, right? So I think in some sense, if we were to summarize, and maybe Krishnaram has more thoughts on this, but essentially thinking about it as accuracy monitoring, fairness monitoring, explainability monitoring could be like the three pillars of an ideal ML monitoring framework. In addition, something that actually affects all of these aspects is to monitor if your data itself is shifting, right? So if your data is changing, obviously the three aspects that I listed would be changing, but there are also approaches and techniques which can help you just monitor if your data distribution itself is changing. That is, just to kind of put it in formal terms, like P of X, which is your probability of your data distribution itself is changing, and P of Y given X, which is the probability of your outcome conditioned on your input features is changing. So there are techniques to monitor that as well. And because of changes in the data set itself, you will observe changes in whether it's accuracy or fairness or the features that the model is relying on. So I think an ideal ML framework would look at all these four aspects. Krishnaram, do you have anything to add?
No, thanks, Himad. Superb. Maybe what I would like to add is, so I think the P of X and P of Y given X that Hima referred to are often called as feature or data drift and concept drift in this model monitoring community. So the intent being that even in cases where the data may have drifted, if the relationship between the target variable and the input features is remaining the same, there may be less of a cause for concern. So in addition, I would love an ideal ML monitoring framework uh, to tell me, as let's say a machine learning engineer or a data scientist, uh, when I should take action, what action should I take, and even better if it helps me partially like automate that action. So starting with when I should take action, I think that so one model might be one where, say, I as a data scientist look at dashboards, right? There are lots of dashboards in various analytics and machine learning systems, and kind of keep looking at these dashboards and try to figure out whether something is going wrong. That's perhaps like that's less than ideal. I would love to be in a situation where the system alerts me when there are issues. Yeah, and even when it comes to alerts, it's desirable for these alerts to be very targeted and precise. The reason is that if the alerts are triggered way too often, then as humans we tend to develop fatigue, and we start thinking that these alerts are just not really not real concerns, right? Or say, imagine that I'm on call for a system and I get woken up at 2 a.m. in the morning, and then realize that this alert is not urgent, or it's not even relevant. So that's, I think that would be one behavior I would love, like in terms of providing alerts where there are very few false positives, and likewise there are very few false negatives. At the same time, we do not want to miss any potential issue. The second thought I had was, like, in terms of what action should I take once, say, I am kind of alerted that something is wrong. It'll be helpful for me if I not only know that something is wrong, but understand why that's happening. So what's the root cause behind the issues I'm seeing? So what's the root cause behind, let's say, your drop in accuracy or prediction, uh, probability drifting, or some feature drifting over time? So is that coming from, perhaps is the drop in the prediction accuracy coming from maybe some features or some segments of the data? So being able to understand where this is coming from, ideally, like, the system should tell me which segment or which features are responsible. And the last step is, like, given that I have understood when I should take action, what action should I take? If I can even be helped in terms of taking those actions. For example, is this the time to retrain the model? Is this the time to perhaps collect a more recent or more relevant training data? Is this the time to maybe even just think from scratch? Maybe the assumptions that were valid at the time of model training are no longer valid. So do I need to kind of start from a clean slate? I think these are the kind of things where it will be helpful if the system provides such insights. And even better if, say, when it comes to something like retraining the model, if there can be mechanisms to tie that back with the training system and trigger the retraining, I think those will be even better. Oh, so maybe related to this, I see another question which is kind of very closely related. I'll just read that question. So this question is about, how would we monitor accuracy for models in scenarios where you rejected applicants? There is no ground truth to compare it in production. So I think this question is alluding to the fact that in many real-world situations, we do not have access to ground truth in real time, or even maybe after several days or weeks in the case of, say, lending. This is very common. Say, maybe exceptions would be domains like, say, online like tools, right, or recommendation systems or search systems, where often you can use the user feedback as kind of some flavor of ground truth or feedback signal. So that this is in such domains, it becomes very hard to measure the accuracy or other performance metrics of the model. Instead, there may be ways to use proxies. So for instance, when the model, when would a model degrade in accuracy? Often this is the case when as Hema mentioned, the P of Y given X is changing. The relationship between the target variable and the input features is changing. So often these changes are accompanied by changes in the input feature distribution itself. So let's say that there is a model which was trained over data from maybe applicants in a 20 to 30 age range, and from, let's say, one state like California. And let's say that we are now applying this model for those who are in the age range 50 to 60 and say in New Hampshire. There's no reason to expect that this model would perform as well on this second demographic as compared to the first demographic. So again, even in the absence of ground truth labels, we can use such changes in the data distribution as an indicator that something may be going wrong. The other subtle factor that can be used is, if we monitor the importance of the features, and we start seeing that the features which were important early are now no longer important, or the ordering of features by importance has significantly changed, that might also be a cause for concern. So there was a recent blog post from Google AI where they noticed that in the absence of ground truth, using the feature importance was helpful to discover the issues early on. These are some of the ways in which even when ground truth is not there, you can do this. So another approach is often by kind of mapping to say the training data. So the way this is done is in at the production time, we do not have access to ground truth labels, but if we have access to variables which kind of capture how much the data has changed. For example, let's say that the key variables are age and maybe gender, and then if we see that the joint distribution of age and gender has changed in production compared to training data, we can now reweigh the training data or the test data in terms of the observed distribution of the gender and age, and recalculate what we think might be the current accuracy of the model. So I have seen techniques like this also being used in some cases. Hema, is there anything you would like to add?
Yeah, I think that kind of covers a lot of the pieces. Thanks, Krishnaram. So I think just to maybe I'll just kind of summarize. So I think whenever you don't have like reliable proxies for ground truth, so it would be, useful to sort of do things which may not entirely rely on ground truth, right? So that's basically what Krishnaram was summarizing. And that could just be the change in your input features distribution, as we are saying P of X, or it could just be the change that occurs in the features that the model is using when making predictions, right? So these two themselves could actually be very helpful in determining if like there is further monitoring that's needed even without access to ground truth. So yeah, like just a summary to that, right? So, and then there are also some approaches that are, typically inspired from approaches and things like causal inference, where people try to sort of impute the labels of the newly originated points based on finding similar points or nearest neighbors in the existing data or in the new data for which could be partially labeled, right? So those are also approaches that you can use to get proxies for ground truth. Of course, they'll not be as reliable as like actually having the ground truth, but that can help you like give some indication about, if you might need to recalibrate your models, right?
So let me take, let me just read out another question that has been submitted. Are there any regulations imposed when it comes to natural images? Is there an enterprise use case in such a setting? Um, um, I think the question is perhaps referring to like monitoring of the distribution of maybe computer vision models,
Mm.
perhaps. So I think in terms of regulations, the closest that I can think of is domains involving humans. So these are typically like facial analysis or facial recognition or similar like models and systems. There is a lot of discussion around where such systems can be used and what are the requirements of such systems. There are even regulations perhaps in progress, but I don't know whether there is any regulation which has already taken effect. Uh, I think more broadly, from a technical angle, uh, it is definitely useful to be able to monitor such models as well, because we are seeing that there are a variety of applications where computer vision is becoming more and more relevant. Even last week, I was at a conference, and more like an industry conference on Edge AI and Vision, or Embedded Vision Summit, and there are, it was interesting to see the variety of applications ranging from, say, automotive technologies to retail to health and safety to consumer electronics, where various computer vision based models are being deployed. Some of these are end user facing, and some of these are perhaps B2B and enterprise facing, so we may not get to hear about such models a whole lot. I think in those cases also, it's desirable to have tools to monitor the performance of the models. And in the cases where, again, ground truth may not be available in real time, to be able to monitor the distribution of the images over time. So we have also been thinking about how to uh, monitor such complex features, right? Features which are not tabular data sets, but features like NLP or computer vision based data sets. And there are approaches starting to emerge on how to monitor the distribution of such complex features as well. So Hima, anything you would like to add?
Yeah. I think that kind of covers, a lot of the pieces that, yeah, as of now, I'm also not aware of any regulations that specifically exist, but I think due to the push of some of the research, which kind of highlighted that, these facial recognition systems specifically, right, like one kind of vision based system, uh, so that they were sort of like achieving lesser accuracy on like women of color and so on. I think those kinds of like research by different folks, like including Timnith and Joy and so on, so they have brought to the fore some of the issues with these kinds of systems, because of which even big companies such as IBM or Amazon have rolled back some of these tools because of these kinds of gaps. So I think there is definitely now more scrutiny into those tools, and people are going to check such tools a lot more. But as of now, even I'm unaware of like any regulations that are put in place for these kinds of tools. But I think definitely there are efforts being made, and there is work that's being done to even think about what such a legislation would look like. Yeah.
Yes, for in case you're interested in learning more, Hima is referring to the
Gender shades.
phenomenal gender shades work from Timnit Gebru and Joy Bolamwini. It's great to see that Timnit has just been recognized as one of the top 100 influential people of 2022 by Time magazine. Um, so let me read another question. When it comes to machine learning models that make business loan determinations, how do you prevent unintentional bias in the model? Hima, would you like to take this?
Yeah. So I think I'll generally talk about. I think this question is touching upon whether it is business loan determination or even contexts like hiring, how will you prevent undue bias, right? So let me start by discussing a little bit about that term bias, because I think it is often overloaded. So when we, I mean, I think when we give data to a machine learning pipeline or a system, it will capture the bias, or quote unquote the information or the patterns available in the data, right? And not all kinds of bias is bad. So there are certain kinds of undesirable biases that we consider as bad, and that they should not be in the models, right? So for example, the things that we can immediately think of the top of our head are things like gender biases or racial biases. And those are the things that are often, models are often scrutinized for these kinds of biases these days, right? Of course, there could be other kinds of undesirable biases, like we were thinking about this context where a model is using completely relevant features to make prediction, and that's a different kind of bias, right? It's also an important thing. If your model is using junk features to make predictions, that is a bad bias, that's an undesirable bias. But I think when people use the term bias, loosely in conversation, they're referring to gender/racial biases. And I can touch a little bit upon how to sort of detect such biases and prevent such biases, right? So at a very high level, there are several statistical checks that fairness literature has to offer, which will help us detect these kinds of biases, right? So, for example, there are some common metrics that people are often using to detect such gender and racial biases. So, one of it is statistical parity, which means the probability of somebody getting a positive outcome should be independent of their gender, right? So, the probability of getting a loan for say male versus female should be the same, right? So that's what statistical parity is enforcing. Then there is another notion called as equality of opportunity, which is basically enforcing the fact that the probability that your model gives a loan to somebody should be independent of gender, given that two individuals that we are comparing roughly have the same potential of repaying the loan, right? So this is basically saying that in some sense, if we knew two people were equally likely to repay a loan, then the probability of them getting a loan should be independent of their gender or race, right? So that is the equality of opportunity. Then there is counterfactual fairness, which basically thinks of this as, if I take a data point and then flip the gender value, the value of the gender variable from say male to female or other, then the outcome from the model should not change, right? So these are some generic tests that we can use to detect if there are biases. And then we can build models that sort of use these tests as constraints when building the model itself, to actually sort of prevent these kinds of biases from accumulating in the models, right? So that is, I would say, like a very bare bone first cut solution to thinking about how to develop models that are less likely to have gender or racial biases. Krishnaram, do you have stuff to add to this?
I think Hema touched upon several different dimensions. So I just was looking at a tutorial that we had presented last year, and in that tutorial page, there are links to several other tutorials, including tutorials that Hema has presented, and several Arvind Narayanan or Kate Crawford at various conferences, which go into the kind of the notions of bias and fairness in a lot more detail. So I just shared that in the chat here. So let me go to say another question, which is about how do we do proof of concept in large enterprises and explain the value of say explainability or perhaps model monitoring or fairness tools to perhaps maybe the decision makers, right, to the leaders or business decision makers or other stakeholders. So I can kind of maybe take a stab at this. So I think this perhaps this question is alluding to. So let's say that in a large organization, the interest or the desire for adopting responsible AI tools can come at different levels, right? One model it might start at the top leadership, and then there is an emphasis that trickles down throughout the organization, not just in terms of say just verbal statements, but also in terms of the incentivization, how people are rewarded, how projects are prioritized, and so forth. The other model which complements that is there is often bottom-up interest from maybe machine learning researchers, practitioners, and so forth, product managers, and so on, who want to kind of adopt such tools. So in the case of the latter, or even in the case of former, it's very important to I would, in my view, like articulate why doing such tools or adopting such practices is important for the 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 business, what the organization cares about. So while say articulating the socially responsible dimension is great, often when things are really tough, the organizations tend to focus on what matters immediately to the organization. That's why I think it's important to emphasize that, say, something like an explainability tool is not only helpful to detect say undesirable biases in the systems, but also perhaps help maybe debug the root cause of certain issues, or respond to issues observed in production, reduce the time and effort that a data scientist or an ML practitioner would otherwise be investing. So I think one of the benefits of having tools at our disposal is that they help reduce the time it takes to detect issues and fix issues. Often, say, when the model degrades in performance over time, if there are not enough tools, it may be a matter of several days or weeks before the issues are detected and resolved. That translates to perhaps a lost business opportunity during that time frame, and also it also translates to the lost developer or data scientist productivity. So instead of a data scientist spending several days and weeks debugging issues, it may be better for them to perhaps build the newer models, or do better, come up with better machine learning models and systems. So another question I see here is, how do we baseline the model and assert the size of the model drift?
Yeah.
Yeah.
So I can get started, and then maybe Krishna, we can add more to this. So I think there are different sort of like scenarios here, right? So we also discussed earlier a little bit about what if ground truth was not available versus ground truth was available, right? So let's take the simple scenario first, where you have the model, you trained it on some data before which had ground truth, and now there is new data that is streaming in, and for that also you almost readily get ground truth, let's say, right? So in that case, this becomes slightly simpler, because we can say that, you'll benchmark the accuracy of your model initially, right? And then you will get a number, and then as time progresses, at each time point you will then measure the accuracy of the model and make sure that it does not go beyond a threshold, right? So for example, let's say you started off with a base accuracy of about 89%, and if you don't want your model's accuracy to go below, like, let's say 83 or 84%, you can keep a check on that, and then monitor the model to sort of satisfy this condition, right? So that gets easier if you actually have ground truth, and if you're consistently able to evaluate accuracy, right? Now, without that, then we essentially need to rely upon two of the other facets that were mentioned before, which is the input feature distribution of the data itself, that is P of X, right? So now you have to monitor how P of X changes, and what is a significant change, right? So, and even that itself can be sort of computationally challenging, because P of X is essentially like a joint distribution of all your input features. So, sort of like keeping a check on that in itself could be hard, because there could be like dependencies between the variables and so on. But a way to sort of simplify this is, let's say we consider all features as independent, which means, let's say there are three features, x1, x2, and x3, and we say that these features are all independent. So p of x, which is the joint distribution, will just be a product of p of x1 into p of x2 into p of x3, right? So if we have such a scenario, and let's say we have identified the actual distribution of each of these features earlier, let's say x1 is Gaussian with some mean and then variance, and then you can keep tracking the mean and variance of x1. And if it sort of, let's say, doubles or like goes beyond one standard deviation, if the mean changes beyond one standard deviation, you can say that a change has occurred in your x1 values, right? So I think such checks can be kept. Or, another thing that Krishna mentioned, when we don't have ground truth labels, is we could potentially use like the feature importances of the predictions that the model is making, right? So for example, we can track that the model is, let's say, on an average relying on these kinds of features when it was the baseline model, and then over time, how is that feature importance changing across time, right? And if like certain features are becoming more important than the other, or if the feature importance is, let's say, increasing by 25% for some features, we can put an alert on that and then monitor that, right? So these are all the different ways in which we could sort of precisely detect how the data is changing or how the model is changing.
Thanks, Himar. So let me just mention take the next two questions, which are broadly about perhaps tools for machine learning model monitoring, both open source tools as well as tools offered by several cloud-based providers. So I would say that the field of, say, model monitoring, or kind of also related dimensions like, say, bias, fairness, explainability, and so forth, or have been improving a lot over the last few years. So there are a number of tools available both in the open source and commercial tools. One of the things that we have heard a lot, or we see when talking to customers, is that while there are many such tools in open source tools, for example, there are a number of open source tools for measuring biases or even mitigating biases, or for model monitoring. Often the integrating such tools with production systems requires a lot of, say, maybe configuration tuning, or tuning some parameters, figuring out how to set different parameters and so forth. So that is one place where often we see customers asking for fully managed systems, wherein somebody doesn't have to spend their time and effort figuring out how to integrate, say, from amongst several open source alternatives with their production system. So this is a reason, even when I was part of the AWS machine learning team, we decided to provide a fully managed service as part of Amazon's machine learning capabilities. But often these the capabilities offered by the major cloud providers tend to focus on the what's common across customers from all different industries and all different requirements. And the intent there is to provide whatever is the kind of the basic functionality for whether it is model monitoring or explainability or debugging or auto ML and so forth. When it comes to, if a customer requires more advanced functionality, for example, functionality such as performing root cause analysis, or deciding what actionable steps they can take and so forth, that's where more advanced tools, often in the commercial domains, become more relevant. We are almost at the close of the webinar, so let me ask Hima a broad question about what do you think are some of the key trends in, say, academia around the domains that we discussed, like model monitoring or responsible AI? So if you have some suggestion for the attendees of the webinar, what would those be?
Yeah. So I think these fields have, I mean, different sub fields within this broad area of model monitoring have evolved very differently. So I think I can touch upon some of the latest, quote unquote, trends in these fields. So one of the things that I can probably start from explainability, because I spend a lot of time thinking about that. So one of the things that has sort of come to the fore in explainability is, I think, this recognition of the fact that we have a bunch of different techniques which are all potentially doing slightly different things, and there is less understanding about which use case requires which kind of technique, right? So I think there has been a lot more sort of thinking or like academic work of late around which methods to use under what scenarios and when. It's not a completely solved problem, but like I think there are basic steps being taken towards addressing this problem. So that's only happening because there are already a whole gamut or a slew of techniques that are being used to sort of, or that have been proposed to sort of explain models, let's say in a post-hoc fashion, right? Coming to fairness, I think with respect to fairness, a lot of the details at this point is about customizing or operationalizing fairness, right? So there have been like a bunch of different metrics that were proposed, whether it is like group fairness or some of which constitute some of the metrics that we talked about earlier. There is individual fairness and so on. But again, the question that is sort of on everybody's mind, or which there are not very strong answers to, is there some kind of a taxonomy or a characterization which helps us realize that under these scenarios, for these kinds of applications, this notion of fairness could be useful, right, compared to any other notion? That's important. Why I'm emphasizing on which notion should we pick is because there have been theoretical results which demonstrate that you can't simultaneously satisfy several different notions of fairness, right? So which notion is better and for which application is another sort of like a debate or discussion that has been happening in various circles, including academic circles. And I think the last piece regarding the data set shift or concept drift that we talked about, I think there is yet another slew of algorithms, but they differ based on their computational efficiency. So depending on, like, I think, and there have also been efforts to sort of detect these drifts accurately but in a computationally efficient manner, and how to do that with less and less compute is, I think, one of the sort of like trends that has been emerging in that area. So,
Um, Thanks, Hima, and thanks to all the attendees who are watching this live and asking several interesting questions, and also thanks to those who will be watching it afterwards. So this brings us to the conclusion of today's webinar. We are very excited to start the AI Explained series, and we look forward to having more such webinars in the future. Thank you all.